Okay, well, I want to dive in pretty quick here to something that is near and dear to my heart, and I'll give you my little nerdy sort of funny story of how I first um, got into this. But I went down a rabbit hole, especially during COVID. I ended up kind of writing I guess what I would think of as a graduate level like course on quantum social theory, and I ended up teaching it a couple times. Like the first time I just called up a bunch of my friends and said like you don't have anything to do, it's COVID, like you're gonna every Saturday morning you're gonna come to this Zoom call and we're gonna learn about quantum social theory together. And it really blew my mind. And so this whole kind of series has been about it's called Models for Leading Change. And I want to present, I don't think quite a model yet. It's more of a framework, some big ideas. And then I think like a model wants to happen. So maybe we together can start to explore and like begin to sketch out the contours of what a model for leading change using this revolutionary, disruptive, like framework that is kind of like an opposite pill in the social sciences in many ways. You know, is there some model or is there some way that this could be applied? Yeah, it's controversial. Some of you might be the skeptics in this discussion too, and that's okay. I'd love to hear from you if you think this is just, horse blank, right? Horse shit. I guess I can say it. It's my show. So, so, uh, uh, so I'd love to hear from the skeptics. I'd love to hear from the people who have some ideas about how this could apply. And I'm going to just share with you some of my thoughts, and then hopefully we'll have lots of interruptions and discussions throughout the session. All right, so I want to tell you the story that started this whole thing for me, which was I was reading a book in 2016 or 2017 called Hyper Objects by this dude, Timothy Morton. He is just this fascinating thinker. And probably that year, this was the most important book I read. Probably in 2 or 3 years, it was just blew my mind, changed my view of the world, and had me just thinking about things in a very different way. So it's not a light read, and I recommend this book, especially if you care about things like climate change and, how can we grapple with some of these big issues that humanity's facing right now. Anyway, I read the book, and there's just kind of some one-off lines in the book where he says the most, any kind of philosophy that's worthy of today, it must be able to address the most sophisticated sciences of the day, which he said was general relativity, quantum mechanics, and ecology. And then there's kind of like this one-liner in there where he says, he talks about like geese, Canadian geese, and he says that they've got these like quantum scale magnets in their eyes. New research has discovered that geese have these quantum scale magnets in their eyes that allow them to perceive the quantum signature of the Earth's electromagnetic field. And this is how they are able to migrate tens of thousands of miles back to the exact same square meter where they started from. And when I saw this, I was just like, oh my God, like really? Like, holy crap, if geese have this capacity in them, like then humans must have, like there's gotta be like some evolutionary connection, and like what does this mean, and how could this? And so I was looking up the studies where this happened, and I went and posted it on Facebook that afternoon. I was like, la 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 la, like this is crazy, like, and nobody commented or even liked the study that I posted. Facebook algorithm probably was like, get this out of here, this is not on brand for us. Anyway, I I was like, and then about an hour later, so I was actually reading, I was in Vancouver on a research trip, and an hour later, I was walking down, didn't live here at the time, I was walking down Davie Street, and um, the weirdest thing happened to me, which has never happened to me before, but this angry crow, like, dive bombed my head and he hit me with, like he flew down at me and like hit me with his feet, and then he came back and tried to do it again, and I'm like, hey, get away, and my adrenaline's all like, what the heck just happened? It, like, this thing flew out of nowhere and hit me in the head. And uh and then when so I took as soon as I got away from this thing, I was like, huh, like, I don't know. It's just some weird, but it made a connection for me. I was like, this is so weird that, like, the day I'm posting about birds with magnets in their eyes, this crow like attacks me on, in the street. Never happened to me before. I'm like, you got my attention. I'm gonna look into this. Whatever. I took it as a sign. So that's the story that started it all. And so, but I want to just ask, because I think most of you have some probably deeper level than average of experiments in quantum theory. So the idea of the split gate experiment and entanglement. So who just has like some, you already know this and we can gloss over it. We'll talk about it, but we don't need to go in depth. Who's, just raise your hands. This is, yeah, yes, yes, yes. Okay, I think you do. I think you're just, yes, you all do. I know you do. But okay, so if you want a refresher, the split gate experiment is this idea of trying to figure out, is light photons or waves? If it was photons, it would be like little marbles or little bullets going through these two split gates. And what you would see on the other end is like, so there's going to be like a film on the other end that, like, where the photons land. And if it was particles, it would be like bullets or marbles, and you'd just see these two solid bars. If it was waves, you would get like an interference pattern, and you wouldn't see two solid bars. You'd see this kind of spread of bars across the end, because this is what would be happening, is these waves would be going through these two splits, and then on the film at the end, you'd see like all the bars from where those interfering waves would kind of hit on the end. That's very technical language, where they'd hit on the end, as you can tell. And so you get a pattern like this. This is what it actually looks like on the film. Now, the weird part about this experiment that's been done over and over and over again, as many of you know, is if people watch, you get two bars. If nobody's looking, you get an interference pattern. So somehow the way reality works at the quantum scale is somehow observation seems to change what shows up, at least in the experience of the one who's observing it. Now, this is very controversial. There's all kinds of theories, and people have proposed different, what's actually going on, and is it like this or not? But the upshot of this whole thing is that for some reason, you watch it, you get particles. You don't watch it, you get waves. Or maybe it's not waves, maybe it's probabilities or something, but you get a different pattern on the film. So I want to just pause there and see if anyone has anything to add. Maybe someone is more versed in physics than I and can build on that, or throw in a provocation, question, anything. All right. Yes, Hugh.
I'm curious, like, so when they film it, if the observer's there, then they see this change, but then observer's not there, the film picks up the original state, or how do they know the original state from the
That's right.
altered state?
That's
How do
right.
they know? So
If you're
is it
not,
okay?
so it would be called, or one thing that it has been called is a measurement event. So if you place a device that can watch the photon going through, and that tells you which slit it goes through as an observer, if that's happening, if something's tracking where that photon's going through, you get the 2 bars. If you're not tracking where the photon's going through, you get wave pattern. You get this, the thing that's on the screen.
So how do they actually know if there's not somebody there actually observing, or because isn't the
Because
camera observing?
because
Isn't
this is the pattern you get on the film.
I got that with the pattern on the film of the observed state, but how about the original state? How do they know the original state?
Because this is the pattern you get on the film.
So the camera can do it, but the camera can do it, but they're weak, like if there's an observer there, then it changes the
No, the
camera
film,
image.
because you're not watching, the film isn't watching the slit. You have to be watching the slit right here. Does that make sense?
Yeah,
You have to be watching the photon go through the slit. This is just after the fact, which is also crazy because they can do experiments, a very similar experiment to this, where you can watch something after the fact, but it actually changes what happened before. So you can literally observe something and it appears in physics, in how we would look at physics, it alters the past by observing something in the present. That's even weirder.
got it.
Okay, yes, Emmanuel. Oh, yeah.
So I think I was thinking a bit the same. So it's not being filmed, right? Like what you're talking about, the viewing screen is what we see at the end. So if it
That's
was
right.
watched or if it wasn't watched, because at first I was like, the lens optics must have something to do with this. But you're saying like if there's somebody in the room watching, we're gonna get a different end result than if
Yes.
there's nobody. Is that it?
Yes. You have to have an observer like looking at these 2
Yeah.
slits. I don't know if you can see. Actually, I wonder if
Yeah. But what my question is, it's sort of at the end of the experiment on the viewing screen, the result will be different.
that's right.
So we're not recording this and then replaying.
Yes.
Okay, that's crazy.
Yeah, so like let's just see, does this work? Oh, sorry. Sorry, I thought I could get a little laser pointer going. Can you see my cursor hovering over here? Yeah, okay. So right here is, you got to be watching this here, and you have to watch which slit it goes through, and then that's going to change the result that you see on the film. Is that clear? Yeah, okay, good.
Hey, Justin, can I just
Yeah.
put in one thing for clarity?
Yes.
By film, you don't mean like a recorded film, like through a lens on a camera. We're talking about the contact surface as a film that reacts to light hitting it.
Exactly. That's really great clarification. Thank you, Logan. Okay. And then another kind of interesting thing, which was actually brought up by, let's see, by Einstein, because he wanted to disprove quantum mechanics, was this idea of spooky action at a distance, or entanglement, which is that you can have 2 photons, and if they're entangled, so if they've been kind of connected in a quantum system, I guess you could call it, but you can have them be like light years apart from each other, like, or like one is somewhere elsewhere in the universe, but if they've been connected or entangled, what it's called is that the instant you change one of them, the other one is going to instantaneously change. like outside of like what we would think of as causality, like because causality has to happen in time. So the fastest it would be able to happen is the speed that light travels from one to the other. But this change is going to happen instantaneously outside of space and time causality. And it's baffling. It was baffling when scientists actually, well, first of all, when they realized mathematically that this would have to be the case, and then when they proved it is the case, it's baffling. How does this happen? It throws our notion of how causality happens in physics on its head. So any observations quickly or reflections about that one? Yes, Emmanuel.
Hey, sorry, this is a breaking news for me. I'm a biologist, so I could talk your ears off about malaria, but not quantum physics. I just have a question. So
Yeah.
if I'm in the room and I have my eyes closed, do you know it? Have they done that? Like if I'm not looking, but I'm in the room, does it change? Do I have to be looking?
Okay, well, so I'm not a physicist either, and I'm not even a biologist, so I have to be careful what I say to you. I can point you to many videos and many papers on this. So it has to do with, are you measuring it? And so it's not so much, you're not like you with your eyes are not going to be able to see a photon going through a slit. But you can put a device there that measures it for you. And if you're paying attention to that, it's going to shift how it shows up. So I don't know the answer to your question, and anything I would say after that point would just be utter BS. So I will send you the syllabus for the course that I wrote, and it has many, many, many references and things that you could dive into if you're as nerdy as I am. Is that fair? Okay, good. Okay, good. Okay, cool. All right, so anyway, that's the gist of it. And what this amounts to is that quantum theory poses a big problem with respect to our idea, to our whole worldview about what is reality, who are we, what is this whole thing about, and especially with respect to what causes things to happen. It really throws a wrench in our gears. So the things it's going to challenge is like, what's the universe made of? Because the prevailing scientific worldview that all of us got educated in school and that we grew up in is physics is about material things, and that what causes things is material things. So if I want to, there's no room that physics, that mind, that consciousness is a part of physics. That's not the view we grew up in. It also challenges our idea about, are things determined or not? Because even when you're measuring, you just don't know where the particle is going to show up on the film. You can predict with probabilities, quantum probabilities, but there is no way to predict where that particle is going to show up. So it changes our view of like, if you wound the universe back all the way up to the beginning and let it unwind again, the prevailing scientific view, whether we like it or not, is that it would unwind exactly the same way. It might not seem like consistent with our intuitions about reality because we like to think we have a choice, but the prevailing scientific view says no, actually it's just all determined. But this quantum theory throws a wrench in that, maybe. It throws a wrench in our view of time, because if you can change something in the present, if you can change the way you observe something in the present, and it goes back and alters what happened in the past, what? And it changes our view of space as well, because if two electrons are light years apart from each other, but you change one and it instantly changes the spin on the other, then what space, what? And it also changes our idea that there's a clear-cut distinction between the subject and the object. which we all kind of think like, I'm in here, reality's out there. I can see reality and interact with it, but we're separate from each other. We're not the same thing. But somehow, just by looking, it changes the way reality shows up on the quantum scale. What does that mean? It means somehow I'm like connected to this thing in a way I didn't know. So any reflections here? Oh, I see some things in the chat. Haven't looked at those for a second.
Justin, I
Yes.
can't figure out how to raise my hand.
Okay. Okay, good. Well, thanks. Thanks for speaking.
Bad when I have a tech background.
Yeah.
Fascinating stuff. It's sort of funny because yesterday I was having a conversation with somebody who said that Elon Musk actually said that we're living in a simulation.
Uh-huh.
And if you start thinking about, is it a simulation? Like all of reality is simulation. It's just, it's like we're creating this AI, but somebody else, some force or whatever created this AI beforehand. You start thinking about it that way, it sort of seems like you could have craziness in it, right? Like stuff that doesn't really make sense.
Mm.
Just like you have an AI, right?
Totally. And then it's like, okay, we're in a simulation, and then did the people that simulated us, are they in a simulation? Like, it's like, whoa, what's going on here? It's crazy.
Actually, the simulation's taken over, so there's no creator anymore.
Yeah, it's a wild time to be alive.
It's a little mind-boggling at the least.
Yeah. Okay, cool. Well, so thank you for that. And I saw some of the chats. Thank you, Scott, for that interesting post on your conversation with ChatGPT. I clicked the link. I'm going to review that later. Beautiful stuff. So here's the thing, is that for a long, long time, quantum physicists have said, well, that's all what happens at the quantum scale. But but as soon as we get up to this scale of human life, biology and even chemistry for the most part, and like the world that we know that we can interact with, none of that applies anymore. It certainly doesn't apply when it comes to social reality and all the things that we deal with in our life, because the quantum scale is very, very small, and that's the only scale that you can get quantum effects. As soon as you get up into brains, which are too hot, they're too wet, they're too big, you're not going to have any of those quantum effects anymore. And that's been the prevailing view for a long time, which would mean if we're thinking about something like leadership, leading change, we shouldn't think of it in any way in terms of quantum theory. We should think of it as classical physics. We should think of it as, I do something and this gets a result, and then I can do another thing and get another result, and that's how it works. And that could be true, but I'm here to offer some provocations that maybe that's not the whole story. Maybe. So, as we've done in previous examples, I would like you, just for the fun of it, to think of a change you're committed to. Something that you want to have happen in any domain. Could be your health, your family, your community, the world. It could be related to something as simple as losing 5 pounds, or as big as climate change. It could be anywhere, anytime, anything, any place. And then I want you to just think of that change in terms of some of these challenges. Some of these challenges with how this quantum stuff makes us think about reality. And I want you to just imagine for a second that, well, before we get into it, I'm going to try to build a case. I mean, I could take hours and hours, so I've only probably got about 10 minutes to try to build this case. So I'm not going to do the best job today, but I hope I will at least stir you to be interested in this. But think of, okay, what if the universe is partly made of mind and not just physical things? What if the outcomes are not predetermined? what if time isn't what if the future is actually connected to me right now and the past is connected to me right now and it's all kind of blurred together in this weird thing? What if space isn't what we think it is? And what if I'm not separate from the reality I'm experiencing? What if I'm actually am the reality I'm experiencing in some way? Now, think of your change that you want to cause and just ask yourself, how would you hold that change differently if any of that was true? Just imagine, just speculate on that for a minute. It might not have an answer right away because it's not an easy, it's a totally different paradigm. It's not an easy thing to grok, but if you do have any thoughts about that, if anyone has any thoughts, off ball, off the wall, interesting thoughts, I'd love to hear what you have to say about it. Dave Brown removing me of the movie Arrival. Oh, such a great movie. So good.
I'll say something, if it's appropriate.
Yes, yes.
The movie Arrival poses a model of reality whereby time is sort of non-linear, or at least with the appropriate language, a species could see all of time at once in a matter. That's one thing that I find deeply interesting. I know it's just a movie, but it'll rattle the cage of some people, but it's a great way to sort of shake up a worldview. The other guy that I posted to the chat is a scientist named Donald Hoffman, and he has some really interesting ideas about consciousness and sort of riffing on, or way beyond riffing on entanglement theory. Anyway, he's a guy worth listening to. I think the video that I posted will be great fruit for contemplation. Anyway, I'll leave it at that.
Thank you, Dave. Awesome. Emmanuel.
Yeah, I feel like it's interesting because I try to keep in mind that you're doing this in terms of leadership, but just what's been happening in the last month, right? Like I'm sure all of you guys have heard people using the podcast app to create fake, well, AI apps, podcasts, you know, and I've just been saying and thinking like reality is over, right? Like I think, and I think it's because there's a shift in our reality concept of time, I guess that's coming up soon with artificial intelligence. But to, you know, just to riff on the Arrival movie, there's a movie called The Double Life of Veronica by Krzysztof Kieslowski. Most people have seen Red, Blue, White movies, but before that he did a movie, and I saw it when I was quite young, and I remember thinking like people that talk about past lives and future life or whatever, they really lack imagination. And Krzysztof Kieslowski really got it because in that movie, the character has multiple lives all at once, right? And that's it explains like when we get a weird feeling about something, or like it's your other person going through something, right? And it's like it's a lot more original than just thinking about like remembering past lives. I think it's just like having all these lives at once, you know, and it's just interesting to think about things differently like that.
Thank you. Thank you. Logan.
What this conversation is bringing to the forefront for me is this idea of like causality and my like an individual role in it, and how often in leadership we're like, how do we create the conditions or the teams, or like there's somewhere we're trying to get or some result, and this very kind of cause effect relationship with our reality. And this whole conversation is opening up some radically different views and perspectives on how to build a set of practices and approach. And like, you know, now all of a sudden it's like, if there's a global problem, you know, instead of being like, how do I find the presidents and the Elon Musks and the whoever of the world to get recruited to like be the champion, like perhaps inside of this framework, you know, it's you know, in some training that I've done, people assert that, you know, discovering oneself as the source of anything or everything. And I'm like, there's an interesting now scientific reality arising that seems to, at least on a preliminary level, align with that possibility.
Yes, beautiful. Those are the types of intuitions that I think thinking like this can stir. Okay, Hugh, and then you're the last one. We gotta move to some of the juiciest parts here.
Okay, thinking about the double split experiment. So when the observer sees it, it shows up this way, but what's normally the way it is another way. So maybe there's a Platonic way of thinking that there's this archetypal world, that the way that perhaps that it actually is, but what we see is what we observe. So we choose what we observe, and what we see is what we observe, because it's in our mind. Our minds, our thoughts alter the perception of what it is. So if we actually got to the point of where we could actually be in that quantum world, which is something pre that, then we'd like dropping all the thoughts, dropping all the things that are our expectations, dropping all of that, we might actually get a glimpse of what the actual quantum world is. And in our, I don't know if we can alter that, but we might be able to get a glimpse of what that looks like. And that might make a difference for us in our observation and what we actually do and choose to take on, which would alter our reality.
Okay, good. And I want to invite us to consider that, in a way, maybe we actually are interacting with the quantum world in ways that we haven't taken the time to consider yet. So, what's going on here? Here we go. Okay, so I want to just share with you, we talked about bird's eyes. Now I want to talk about the human eye for a second. So this is a little, so here's the eye and here's the retina right here. This kind of area on the back of the eye is called the retina. It's actually an extension of the brain. So it contains all these neurons, and there's many neurons in the retina. I think there's about 120 million rods and about 6 to 7 million cones in the retina. What else do I want to say about this? So this is kind of like one, they're called a photoreceptor cell, but it's either a rod or a cone, and this is kind of what they look like. They have this a nucleus, they have a synaptic body, and then towards the pointing outward, I guess, I don't know how to say this, but like facing the light that's coming into the eye is this part of the cell here. And this is what this looks like. This is like a electron microscopic picture of part of the retina that has all these particular ones are rods. And again, in each eye, there's about 100 to 120 million of these rods and another 6 to 7 million cones. And this is kind of like so if you go in here, like here, there's all these little, at the top here, you see all these little discs. And then this is kind of like this is homed in view of like an illustration of what those discs look like in a rod and in a cone. I showed you that to show you that inside of each of those discs, they have, this is kind of what this all looks like. You have a little molecule here called rhodopsin, or in the cones, it's called photopsin. And now, so you got 120 million rods. Inside each rod, there's 100 million rhodopsin molecules. and so you get 10 to the power of 16 rhodopsin molecules in each eye. And that's not even talking about the cones yet. And what one of these little molecules looks like is, it looks like this, and it's a measurement device. What it's measuring is a photon. So a little photon hits this section of the rhodopsin right here, and then it goes straight like a spring, and that generates electricity, and it starts to send a signal, and that signal goes through the optic nerve back to the visual, whatever the hell it's called in the back of the brain, visual cortex, I think, I can't remember. Anyway, so it goes in there, and then the brain interprets it. So every time we look into the world, are interacting with the quantum world. That's how we see. And there's more to the story than that, but I can't say it because we've only got 20 minutes and we've got to actually talk about leadership. But it's wild. It's just wild. Like, we are quantum beings, and that's the case I want to make to you today. I will send the syllabus for the whole course. There's many videos that explain this way better than I, and I've just focused on this one little thing called vision, but there's a whole argument to be made that you are a walking wave function. You're a walking wave function. You are a infinite, like, wave function of possibility that is inseparable from the rest of the universe, and all the waves are waving together. And it's only when you speak or have a thought, I'm not talking about the subconscious, because the subconscious is just this wave function that's going on. You're not actually thinking the subconscious. It's outside of your actual conscious experience. But when you have a thought, that's when a particle happens in your mind. Or when you speak something, that's when you crystallize, you particularize, you particle something out of a whole field of possibility. So that's the idea here. And I want to come back to this, that maybe in social reality, there's all kinds of other stuff about brains, and there's mathematical application of quantum probability to economics and to game theory and to many aspects of the social science that turns out to be far more predictive than classical probabilities when applied to the same issues. There's a lot of points of data that seem to support a conclusion that it just might be possible that human beings are walking wave functions. And if that's the case, it would change everything about how we view the social sciences. It would change how we think about psychology. It would change how we think about what a human being is, how to alter our behavior, how to address things like climate change. It would literally turn our world upside down. So I want to invite us to just consider that just maybe who we are is not limited into what we thought. So any reflections, thoughts, questions, what's coming up for you? Love to hear a couple people. Love to hear from some people. Hugh.
I think, therefore I am.
Okay, good. Thank you. Christina.
This is reminding me of the Newtonian versus Einsteinian theories of science and healing, and doing vibrational energy work.
Mm-hmm.
And then what else comes up for me is entropy. So we're constantly changing. Um, and constantly, with entropy, I don't know, I'm just starting to look into this. Everything is constantly changing. And when there's not an awareness to it, it is disintegrating. So if, thinking of ourselves as waves of particle and energy and vibration is really exciting.
Cool. Okay, cool. So let's try to apply some of this. Let's just like stir up our intuitions a little bit and just ask some questions just to see what this could mean. So one of the questions I have for you is, where is your mind? Where's your mind? Some people are chuckling. I don't know. No one's had answered. I don't think there's anything in the chat. Where's your mind? Yeah.
In the gutter where it belongs.
Okay, in the gutter where it belongs. Okay, so where's the gutter? Where's the gutter? Like, so the types of questions I could ask is like, okay, let's say Jim's driving down the road and all right, let's say he parks in a park somewhere and there's birds chirping in the trees outside of the window of Jim's truck. Where is Jim hearing the birds chirping outside of his window happening? Where's that happening? Natasha says, in my neural pathways in my brain. Okay. Well, I want to suggest that if we take this idea of quantum brain theory, quantum mind seriously, maybe it's not like that. Like the way we use prepositions and our language and the way we've learned in science ever since the Enlightenment is we've thought that our mind is just in here somewhere. We think that our mind is happening in our head. But what if our mind is non-local? What if it doesn't actually exist in space the way we have sort of intuitively tried to think of it as, but maybe it's not that. And then so what would that change is like, if my mind isn't just in my head, maybe my mind doesn't exist. Maybe it's not limited in space. Maybe my mind isn't separate from your mind, or maybe it's not quite accurate to say that my mind is separated from your mind. So Logan, I'll get you in just 1 second. I just want to get through a couple slides. So there's this, like psychologists in this idea of psychology that's based on classical physics that say that everything happens in the neuron. It's called the neuron doctrine. And the only thing that, the only way that mind occurs is, somehow all those neurons talking to each other gives rise to something we call mind, but we don't know how. But mind is like an effect of that. It's not an actual primordial part of the universe, part of physics. And then all you can do is you can have a theory of mind. So in this cartoon here, it says, the woman is saying, when you've been married a long time, you get to know the other person's thoughts. And then the guy is thinking, no, you don't. and so it's meant to be a joke, but the whole thing is you cannot interact according to the prevailing theories in psychology, you can never actually interact directly with another person's mind. All you can do is have a theory of their mind that's based on your representation of their mind inside of your mind. And then you can watch and see what they do, and then you can come up with a theory of their mind. But if this idea of quantum mind was true, it wouldn't quite be like that. There would be a possibility that you could directly interact with people's minds and that your minds could be entangled in some way. And you're not limited to like some boundary inside your head. That's where your mind is. It's different than that. Yeah, Emmanuel.
Yeah, so we've been on a heated debate here over, are we talking about consciousness or the actual mechanics of the brain?
We're talking about consciousness. Where is your experience? Where is your mind? I would
Okay,
say
so
I would distinguish between mind and brain.
okay, so then we're the only animal with this possible quantum brain.
No, I wouldn't say that at all. I would say plants have it.
Oh, okay, because I was saying, does a carrot have it? So you're saying the carrot has it?
I would say, I mean, this is my idea. I'm not saying, I'm not going to say like, oh, just go look it up. And obviously they teach this in university. But yes, I would say plants do have mind. And if you look at it from a quantum perspective, it's a whole different discussion. We've only got 10 minutes today, but there's a lot of reasons to think that, yes, that could be the case.
But it's confusing because you're talking about the eye, you know, the mechanics of the eye, like, and again, like being the biologist, like that, I was like, okay, that I can wrap my head around. I understand the mechanics of the eye, the mechanics of a lens, right? And then now you're talking about consciousness, the brain and then consciousness. So it's, to me, I compute that better if we're saying that the brain is quantum just based on the mechanics.
Yeah, well, yes, and there's quantum processes. There have been breakthroughs in quantum biology in the last 10 years, and there is quantum processes. Photosynthesis is the only way that the plant can get that much energy from photons is through quantum processes. It's like a split gate phenomenon. The other thing is that plants also have what the hell are they called? Microtubules. And there's a whole idea and literature around microtubules being a quantum coherence, quantum computing device, which could mean that, and just this is all theoretical, it's highly speculative, highly controversial, but if that's true and there's interesting stuff about it, then plants could have consciousness and it could be done in the microtubules. So if you're a biology person and you like that stuff, I'll go look it up. It'll be in the syllabus and you can dive in. Okay, cool. So here's the idea is maybe mind doesn't just exist in the brain. What if the brain is like more of like a radio receptor or like a TV receptor that tunes into the frequency of mind or something rather than some idea that the neurons create the mind? How could that even happen? What, neurons create the brain? Neurons create conscious experience? Okay, well, they're definitely correlated with it, but you show me how that's actually happening. No scientist has ever given any explanation of how mind gets produced by matter. That is a huge question and nobody's ever answered it. And maybe it's because they're looking at the whole thing the wrong way. So, okay, so there's this idea of questioning space and where is the mind. I also want to question the idea of time. This is supposed to be Aristotle. I didn't make this image, I just poached it offline, but I wanted to talk about Aristotle way back in ancient Greece had 4 ideas of cause. He called it efficient cause, final cause, material cause, and formal cause. I'm only going to talk about efficient and final. In today's scientific world, the only form of causation that we allow in our human world, the only form that scientists will even willing to talk about is efficient cause, which is I do something, it gets a result, and then that result causes another result, and it just unfolds like a machine over time. And it's determined, it's material, it's predictable. In fact, your mind has nothing to do with it. There's nothing to do for the mind, and no way that the mind could do it. All the mind does is it's along for the ride. Even if you think you have free will, you probably don't. And there's a whole, we could just go into all that, but we won't. But Aristotle, from the very beginning, had this idea of final cause. Final cause is the idea that the future reaches back into the present and into the past and can change it. Final cause is the idea that the purpose of something, that its future, that its ultimate end is causing it today. If this was true, it would change how we look at addressing things like climate change. And so just think about it for a second. All we have in our experience is now. And kind of even from well, depending, there's lots of different theories about this and everything, but we know in our experience at least that the past is gone. The future is not here yet. So the only thing that's actually here is the present moment. But if you look at it from the quantum perspective, and your mind isn't inside of time and space, your mind is non-temporal, it's non-local, just like quantum particles are. If you're a walking wave function, that could be possible. And then you actually are entangled with the past because you can remember it. So the past is actually here with you right now. And you are entangled with the future because you can mentally time travel there. You can plant yourself in the future. You can imagine, you can be there. And so there is a sense in which the way that you show up and pay attention in the present moment, which you maybe have the ability to do, can literally alter and influence the past and the present through the fact that you're entangled with it. If this was true, it would change how we do leadership. Big time, I promise. It would change our whole idea of what this thing that we're dancing inside of called reality is. Okay, any reflections on that? Logan.
Well, I guess what's coming up for me in this conversation is if observation is seemingly a requirement for something to materialize, then whatever it is that's observing, we'll call it mind, that has me materialize and has what I'm observing as me also materialize, would seem to have to be that non-local, non-temporal consciousness. Yes. And if that were the case, and that, you know, looking at other aspects of physics like the Heisenberg uncertainty principle, where the way we look at things or what we ask of something determines what we can know and not know, then there seems to be this opportunity arising to say that using my perspective, cultivating that, being very intentional about creating from the future, reorganizing my relationship with reality might be like a back door into this whole thing we call reality.
Yes. This way of looking at the world opens up the possibility that reality is extremely participatory, that what you think, how you pay attention, what you pay attention to matters. There's a book written by Karen O'Brien. She was a co-author, I think, in a number of years on the IPCC report. She teaches at the University of Oslo, and one of her topics is quantum social theory. How do you apply that to addressing climate change? Because, you know, looking at it from simply a classical perspective and all the forces that seem beyond human control, and the fact that you gotta get like massive, you know, collective behavioral change, and there's all these other dynamics, it doesn't look, there's just nothing we can do. We're fucked, as I've heard, you know, as some of the sustainability papers that I was reading when I was writing my thesis literally said. But maybe maybe there's another possibility here. Maybe you matter more than you think. Okay, we got 1 minute. So who wants the last word on this? If you're quick, maybe we can have two. Christina.
Well, I can share my experience this morning. My kid's father called me this morning and was talking to me about his vow of poverty and how I need to come to Nicaragua with the children and experience life there, and was creating this whole like new reality of no time, no money, just come, just experience. So it's just very interesting that, you know, it's a continuation of that conversation this morning.
Cool. Awesome. Thank you. All right, everybody. Thanks for coming. Thanks for being here. And come back next week to talk about fears and dreams related to AI. Love you all. Thanks. Bye.
Thanks, Justin.